hello for these today, the last presentation as I've seen in the agenda. So I'm terminating the presentation cycle of the PDF Days Online 2021. And I have always a very boring topic to discuss about validating digital signature in PDF. I have to say this is a sort of follow-up on my last year's meeting, last year's presentation, where I focused more on the integrity proofing of signatures within PDF. And this year I will then shift the focus to more the proving the identity of the signer and the consequences, especially when you validate arbitrary signed documents or documents signed by other systems, other applications, and this will then end up at the so-called green check mark or the red flag. And we will just check with some tests how this can be looked at and how this works and how you can find out whether this is a good signature, a valid signature, or whether there are some problems with the signature, with the certificate, or with perhaps also with the application who is validating the signature. So first of all, a short agenda. I will just take on the thread from the last year, what's validation, then a short overview about signing and validating PDFs, what are the basic technologies, and then I will stress some tests, some real-world tests, where I have some example files where I want to check these example files with different tools in the market and then compare the results. And by the results of this, we will see very clear where are the pitfalls of validation, where are things we have to improve in the future to achieve a better user experience and to get more confidence in the result of the validation. Yeah, first of all, what's validation? Validation is a two-step process in principle. One is proving the identity of the signer. The other is proving integrity of the content. And while the integrity of the content is very closely related to the PDF format, as I've shown last year in my presentation, where we talked about byte ranges and so on, about serial signatures and so on, about certifying signatures, the proving of the identity of the signer is a thing which is completely independent of a PDF. But it's nevertheless important because only both together give you a final result whether the signature in a signed PDF is valid or not. A thing which I think you have also seen last year is that that you have got even the impression that validation of a digital signature within PDF can be even more complex than even PDF-A validation. And we have talked a lot, a couple of years since 2005 about how to validate PDF and how to interpret some results and so on. But I got the impression in the last years that the validation of signatures can be even more complex and can lead to much more problems and things where you need a better understanding about. The special case with PDF is that proving the integrity can be a nightmare due to the flexibility and the capabilities of PDF, a thing which everybody of us is really appreciating, that a PDF can be a very flexible tool for handling documents. But due to the flexibility, you also have a lot of degrees of freedom. The other thing is, as I said, identity proofing is more or less the same process and in other data or document types you want to sign. And this is mostly decided by standards outside of the PDF world. And due to the ETSI standards like CADES, SHADES, and PADES, and other standards as well. So here we have a thing which is more or less a little bit more independent from the PDF base itself. Proving identity of content. As I said, last year's session was mostly the comparison of hash values on byte ranges and the handling of revisions, which can be really an interesting thing in validating a PDF. And but proving the identity of signer, as I said, is mostly specified by these ETSI standards. I will show you a short collection of them on one of the next slides. And they are actually independent of PDF. That means there is no relationship between the identity proof and the PDF standard. And we see this very clearly that the PDF normally doesn't have any information about the signers or the signer if you only have one. So there is no information who has signed a document and what's about his identity within the PDF. The information about this is only stuck in the certificate which has been used for signing the PDF. It's this proving of identity is in the moment a purely technical process, very detailed specification about how to handle this, and we don't see any signature workflow information within the PDF. So there is no kind of audit trail who has signed the document at which time and so on. And this can be things which could become more important in the future, and we are working on them. But in the moment, the actual standards don't reflect this. Just a short collection about the standards we can come to application within signing and validation. The upper part is for signing, the lower part is for validation. And as you see here, the third one in the lower part, the 319.102 version 1 in 1.23 is just a draft. And this can also then show us in a couple of slides later that the policies how to validate and signed PDF will change over the years and over the time, and what we can expect when this specification becomes then valid, I think beginning next year or during next year. Okay. Finally, the user perspective about validation is very simple. So everybody of us who is validating a signed PDF wants to end up with a green check mark. That's it. So we want to just open a signed PDF, see that there is a digital signature or more of them inside the PDF, and then that should start automatically a validation of this, and we want to see a green check mark so that we must not think about this anymore. That's it. Unfortunately, the world isn't so simple, so we will be faced with a couple of different experiences when opening signed PDFs, and I will come to them in a short time. So so is it easy to achieve this? Okay, from my side, surely not. So it is a very hard and complex process. And there are also often put these questions: are there only two choices about validation? That means valid or no valid. So a binary choice. Yeah. Also, I have to say, unfortunately, you will also see in intermediate results, that means indeterminate results, and then it's up to you how to deal with such results. That means and there we could help, perhaps, like a sort of guideline how to handle these validation results between valid and no valid. And but it's not a very clear situation. We need much more a much more broader base of experience within here. And there are also the question about validation: are there signed reference documents, validation results everybody can agree upon? Yeah, In the moment, more or less not. There are some of them within the ETSI plug tests. They are usually doing this after they have published a standard or a specification. Then they invite the manufacturers to do tests with based on this specification to show whether this works or not. And how to exchange such signed documents. But especially from the PDF association side, there is no reference document base with signed documents. There is no such kind like the ESATOR test suite or the Matterhorn test suite for validation results or for signed documents. Could be an improvement in the future, but in the moment, we don't have this. Okay, just to summarize also from last year, there are two types of signatures we can deal within the PDF. One is the certification signature on the left side. The other is the application signature on the right side. The most common one is the application signature. There you can have more than one within a document. That means a serial signatures and so on. While the certification signature, you can only have one per document. It also has to be the first signature in a document, and it determines what can be done with some fields or annotations within the PDF after signing without invalidating the signature. As I said, most applications outside in the market are just using the application signature, but there are still form-based workflows. They are relying on the certification signature as well. Okay, what happens? I think you know this slide also from last year. Signing of a PDF document is that you assign a hash value about a byte range of the PDF, and you embed the information about the certificate. That means the public key, the identity, and the attributes within the PDF. And you can also embed validation data or even references to validation data. And optionally, you can embed a timestamp. That's the basic thing you are doing. You are not embedding the private key. The private key resides normally on a secure device like a smart card or at the remote signing service. And you don't embed this in your PDF. Okay, our test setup, we have what we have set up here to show the different results when validating signatures was made up by three manufacturers of certificates, 3 CAs. One, on the left side, is the Telesec, the German CA with a Telesec Smartcard, and on this smart card you will find a qualified electronic certificate for qualified electronic signature, compliant to eIDAS and so on. This smart card is issued by Telesec actually, and you can use it. It has an expiry date of I think 2 years or 3 years. And yeah, okay, it serves in a lot of environments, also in our customer side, to be used for qualified electronic signatures. As I said, smart card based. In the middle, we have the remote signature service operated in this case by Swisscom. And they have certified this following the eIDAS rules in Austria, in the European member state, and they offer also a qualified electronic signature, a personal qualified electronic signature, eIDAS compliant. They are using, in contrast to Telesec in this case, a short-term certificate. That means a certificate which is generated on demand and then destroyed some minutes after usage. And we are showing what happens if you use such a certificate with or without long-term validation information embedded within the signature. And the last one is a non-qualified one. It's issued by dTrust, another German CA. It's a so-called personal ID, and it represents an advanced electronic signature. It is distributed as a soft certificate. That means you will receive a key file a certificate file, and you can use it, for example, for signing documents as well as for signing emails. Okay, the test setup is very simple. We have some PDF documents. We have these signing certificates, as I showed to you. We are using our own product, the SignLive CC signing tool, to sign these documents, and then we validate the documents with 4 different tools. One is Adobe Reader in the actual version. One is Foxit Reader. And then we use the European Digital Signing Service validation facility online and service operated for free by the EU, and which serves as a sort of reference implementation on how to sign, on how to validate. And last but not least, we are naturally using our own tool for validating these signatures. So let's start with the first one. I'm just signing the Telesec, the document. It's a German text about a fairy tale. We have used here the Telesec Smartcard with a qualified electronic signature. The signer is an employee of our company, Susanne Schleicher, and you see here already the validation result of this signature. It shows to you on the left side that the signature is okay. That means the document has not been modified, and it is qualified and valid. That means the certificate is qualified and valid. In total, the whole signature is therefore qualified and valid. That means everything's fine. This is the typical way a lot of customers are using this for applying eIDAS compliant qualified electronic signatures. Yeah, if I open this signed document within the Adobe Reader, you see a different result here. Here you see signed by unknown and signature is invalid. And this will then lead to the first problem with the users that they call you and say, what's this? You have promised me that everything's fine, and now I'm open this with a common tool. Everybody has Adobe Reader, and why does it show signed by unknown? Okay, the reason for this is lies a little bit more deeper. If we open up the signature details and so on, we get some error information, which shows to us that there is some internal cryptographic library error. A normal user is at this point lost, so he says, what is this? Okay, I have to call the support. How to deal with this, and what this can be. So is the signature now invalid or not? So if we then open up the document in another tool, for example, here I've used the Foxit Reader also in the actual version, I will not get a problem with the cryptographic library, but I will also get some non-decisive information about signature validity is unknown. The document has not been modified since the signature was applied. That means the signature itself is fine, but the identity cannot be certified. So there has been not included in your list of trusted identities, or none of the parent certificates are trusted identities. That means this tool has a problem with the chain of certificates, which leads to the European trust list, and which would then show you, okay, this has been is signed by a certificate derived from a European trusted root certificate. Okay, that's the reason here, the result here. If you open up it in the EU online portal, we get a very simple result: total passed, everything's fine. You see a very detailed report about this, and so on. So this signature fulfills all requirements you need to be to have a qualified electronic signature compliant with eIDAS. Fine. Yeah, and if we now look a little bit more deeper within the the certificate, we see here that the certificate itself uses a signature algorithm called SHA-256 with ECDSA. That means it uses an elliptic curve based algorithm, and this elliptic curve is parameterized using brain pool parameters, and especially this parameterization is actually not supported in some applications and tools outside. One of them, the Adobe Reader. This will change in the future. We are working on this, and as I indicated here, there is a proposal to ISO underway which will heal this. And but in the moment, in the actual moment, this actual signature algorithm, which is allowed on the CADES or on the Etsy side, is not supported within this tool. So that's the reason why the reader says cryptographic library error. Okay, we end up with this result, sign live. As sure, I have constructed this example for this is fine. Adobe Reader says undefined validation results, does not cannot verify this, and the reader says also undefined validation results. EU claims everything's okay. Now we go to the next example, which is an AIS and a remote signature service, also issuing qualified electronic certificates and applying qualified electronic signatures. If we use this service, you see on the left side, everything's qualified and valid, everything's fine. You also see an interesting thing that even it's a Swiss company, it is registered on the trust list of Austria, AT, and therefore it's in the EU and can fulfill the eIDAS compliance. This certificate is a short-term certificate, but in this case, in this example, we don't embed the LTV in information, and the consequence of this we'll see directly on the next slide. If you open up this in the Adobe Reader, we will see, in contrast to the example before, signature is fine, but we cannot check whether the signer certificate is valid or not. That means there is a problem with the validity check. The revocation information cannot be derived, and therefore we can only say, okay, signature is fine, though no modification to the document, but we cannot clearly state who has signed the document. That's the reason for this. And if we open up this in the reader, in the Foxit reader, we have a similar result. Signature is fine. There has been no modification to the document, but we cannot check the validity of the certificate, and also that we cannot handle these short-term certificates. That means the certificate lives normally 5 or 10 minutes. And if the validation happens after the lifetime of the certificate, there can be a problem in some tools because they just state that the certificate has exceeded the time of validity, which is not formally correct, but can be interpreted in this way. Yeah, and if you open up this common usage of the AIS qualified electronic signature within the EU DSS, we end up with a similar result. Here we have the result try later indeterminate. That's a very helpful information for a user. And if you really looks at the validation report, he sees there is some problem with the revocation information of the short-term certificate. And it also states that there is some information about the visual difference of the overlay image of the handwritten signature. You have seen that this was my signature overlaid over the text, and it's just a hint that there could be a problem when overlaying such annotations. But the major problem is here that it cannot be looked up as a reliable revocation information about the certificate. Therefore, try later, perhaps later there could be this information available for checking. Okay, if you want to see the whole report of the EU DSS, it is up to 9 pages long. It's very, very detailed. It shows all checks to be done during the validation process, and I think you get an impression about how complex the whole overall validation process is in this case. Okay, if we now, this is just an excerpt from this detailed validation report. You see a lot of checks. In this case, all things have passed. It means the result of this is that our tool Sign Live validates this perfectly, and the others they have some problems due to the missing revocation information. The reason for this is that we have already implemented a draft version of the EN 319102 standard, while the other tools are still on the published standard, which is some versions behind, but it's published, and we have already done the implementation of the draft one, so it's completely allowed to use this in that way if there is a chance to get the revocation information by looking up, and it's really in this way. So if we make the same thing before, just clicking on during the signing that we want to embed the validation information, the LTV information, during this signing process, then we end up even in the reader with a very perfect green check mark. Everything's fine. The signature is LTV enabled. It can be checked very fine. We have nothing changed with the certificate. The only difference was that we have included during the signing the revocation and OCSP information about the used signature, about the used certificate, sorry. So Foxit Reader is still showing the same result. Signature validity is unknown. The signature itself is fine, but the validity of the certificate has a problem. And so the impression is that it does not use the embedded LTV information in the moment. And I think this can also be changed in a future release and so on. It is not a very serious thing. And if we now open up this signed document within the EU DSS, we see a perfect green check mark, total passed, result is now okay, everything's fine. There's even no warning about a problem within the PDF by overlapping of annotations. This is not present in this report. It's so surprising whether this has been shown up in the other validation report, where the only difference was that the LTV information was not embedded within the document. But okay, we see here very more or less everywhere green check marks. Only the Foxit Reader has some problems with the certificate expiry, but this can be handled very easily. Okay, last example. An advanced electronic signature, as not a qualified one, from a software certificate. All certificates on a certificate chain are registered as trusted, and the root of the certificate chain is member of the Adobe approved trust list. Here we see in our tool again green check marks. The certificate is valid. We will not see any indication that it's qualified because it's only an advanced one. If you open this up in the Adobe Reader, everything's fine, green check mark, no problem. The signature is not LTV enabled and will expire at a specified date and so on. If you open up it in Foxit Reader, everything's fine, no problem. Also, the Adobe Reader uses the AATL for the root certificates, so there is no problem by this. And if we open up this finally in the EU DSS, we see, oh, we are unable to build a certificate chain up to a trusted list because the EU doesn't use the PDF, the AATL from Adobe, and they rely only on the European trust lists, and therefore they can only say the certificate is fine itself, but the signature is fine, but the certificate itself cannot be proved because the certificate chain is not available for checking. Okay, that's it. Overall results, mostly green check marks. Yeah, overall test results. We observed different validation results in our test set. And we have to say that all implementations we have checked comply with existing standards. So there's no failure or thing. They all operate within the degree of freedom. And we have also seen no false positives within this validation session. Nevertheless, the user experience in this scenario could be better because on one side you can see a red cross, on the other side an indeterminate result, and this will not lead to a very satisfying user, and normally leads to a call at the support line, what happened to my signed document here? This could be better. Okay, and why is this so hard in this way? There is no wrong implementation, but the standards offer some degree of freedom, as I already said. We have different or evolving validation policies, how to deal especially with short-time certificates. This has changed in the last months and years in the standards, and will even change also in the future. We have different support of crypto algorithms, and as we have seen here in the last example, different links to trusted lists. That means one category of tools, they really rely on the AATL for advanced signatures. Others ignore them, or they only rely on the European trust lists. So it's not very trivial to assess an ambiguous validation result, and you have to take a very careful look at the result on this. Okay, finally, I came to the end what we need in validation. These are some of my wishes in this way. Some sort of reference database with digital signed PDF documents, which can be regarded as to be valid or invalid. And one good example by this is, for example, the ESATOR test suite. There we have made the same thing for PDF-A, and we have then ended up with a better quality and a homogeneous result of the PDF-A validation process. And such a thing is really lacking in the case of digital signatures. The other thing is that a community which discusses these validation cases and comes, for example, to a common understanding, like it was in the PDF-A working groups at the beginning, whether this is valid or not valid. And this could be handled, for example, by the technical working group digital signature, where we invite everybody to work with us and to participate in this process. And another thing is that the signed PDF should be validatable without proprietary workflow data stores. That means all data necessary to validate a digital signature within the PDF should be contained within the PDF itself, the so-called LTV facility, or the LTV data. This would really help if you store this information outside of the PDF, it's in company databases or something like this, then you end up with non-interoperability, and we have always problems to really verify these signed PDFs outside of this proprietary environment. Here we also have actually some proposals and discussions going on within the TWG DICSIC and PDF Association communities, and we expect here also some standards enhancements. And last but not least, a recommendation is to use LTV information wherever possible. It means make self-contained signed PDFs to have not to come into the problems with validating a PDF with non-available validation information. Okay. What we need in validation, okay, introduction of a signature workflow information to PDF data structures. We are, in the moment, we don't have any information about in this document who should sign the document, or what signature quality should be used for this. Should we use simple electronic signature, advanced, or an advanced seal, or qualified electronic signature? This is not obvious and not documented within PDF. We need therefore a sort of dictionary, a sort of data structure within PDF where we can store this workflow or signature process relevant information inside. And also, which minimum signature quality should be used? Is it allowed to use advanced, or should this be signed with the qualified one? this is not available in the moment. That this leads up to us to a sort of audit trail of the overall signature process, and because we have to see that validation is not a pure technical process, but it has also business and legal implications, and therefore it can be very important to sign a PDF document, a contract, or whatever else with a minimum signature quality. And in some cases, it can be even required to use a qualified electronic signature instead of an advanced one. And there are prominent cases actually out there in the market where this has led to a really big problems with some contracts, and therefore it could be a solution that we can have an anchor for this information within the PDF. And we should end up with an interoperability of the market solutions. So get away from all these companies or market-specific implementations, and really look for interoperable solutions where we can sign a PDF with one tool and validate it with the other and end up with the same result. Okay. Last but not least, focusing on the technical validation could frustrate PDF users and lead to negative attitude. This is a thing we don't want to have, and we should improve this and work against. And finally, I can say signature validation is still a challenge, as you have seen probably in this presentation. And the ETSI has intensified the work on validation standards in the last years very much. And even now, also PDF Association discusses some new concepts on validation of signatures and supporting more real-life signature scenarios. And I think this will help to improve user experience and to build up a more secure validation world within the next months and years. Okay, that was it from my side. Here you see me. I have to say that, yeah, the photo is about 2 years old, so I look more or less the same. We are a company located in Karlsruhe in Germany. We are building software for electronic signatures and validation, and for remote signature signing and so on. We have a certified signature kernel and so on. We are a member of the Cloud Signature Consortium, even a founding member, and we also have some tools doing PDF validation and correction. This is in short way a thing what we are doing. That's my presentation, and now I'm open up for questions. Thank you.
Thank you, Bernd. That was a great presentation, very informative, and we're close to the end of our time here, but I'm going to we have time for 1 or 2 quick questions. What do you see as the single biggest problem in validation?
The biggest problem is to bring down the complexity of the whole process to a very simple result, and even in the case where you cannot say definitely yes or no, to explain the result, and not to leave the user alone with technical information that the revocation list cannot be derived or something like this, because a normal user doesn't know about revocation lists or something like this. And there is a thing I have learned in my former years in IT, where I've dealt with artificial intelligence. It was in the early 90s, and there we talked about a sort of explanation component, which was then a very a big hype in AI, where complex things should be explained in a very easy way to normal users. And this is the thing I see it will be the biggest challenge in the validation development in the next years.
How can clouds can cloud services address all of the requirements that you discussed, or are there of necessity on-file components?
No, I think cloud signing services are perfectly suited for this case. So we have we are dealing with on-site or desktop products as well as with cloud services. There's no difference in this, so it doesn't make any difference whether you are applying this the signature at the cloud service or the cloud service or with a smart card or a local certificate file. The problem we see is that even the cloud services should come to a common understanding to include all necessary validation information when signing within the signature container, and this can then help to validate such a signed PDF even outside of the cloud service. That means you can send such a file not by the cloud service, but by normal email to another recipient, and you can open up this with a tool you don't know, and could then end up with the same result as you have had when signing the document. And this, I think, this is the real goal we have to achieve. Okay.
Sorry, I had a little technical
Yeah,
problem on my side. Yeah,
no problem.
we only have we have time for a brief question more. How does the Foxit initiative for better interoperability fit into your view of what's required?
I've read the proposal, and I think perfectly. It is in the right direction. I've indicated this on my slides in some cases, and that would really help to have more workflow information about the signing process within the PDF. And we still have to discuss how to achieve this, and whether the way which has been proposed within the Foxit proposal is the right or the correct way, or whether there are, could be improvements or other alternatives as well. In the principle itself to include such workflow information, I think, is one of the key factors for being successful with digital signatures in PDF in the future. Therefore, I really will support this, and I'm happy and to look forward for the discussions we will have in the TWG the next time.
Excellent. Okay, last question we have time for here. Acrobat performs document modification analysis when validating. Is this addressed in the standards?
In some way, yes. In the actual standard 32,000-2, you have some sort of an analysis of the structure, and especially whether there are what things can be allowed or not. But I think there is still room for improvement and for clarification. How this document analysis should work, and what this should deliver to the implementers. I think this is not the still the final end, and this is I think there is still room of improvement. And as far as I know from our contacts, especially TWG, the work Leonard Rosenthal is doing there is that there is still work undergoing to improve this and to make this more clearer in the future.